Homework solution 1.14. Repeat problem 13 for an AC system that utilizes two transformers with a turns ratio of 1 to 500 and 500 to 1. Compare the generator voltages and system efficiencies for the system in problems 13 and 14. So the givens here again are going to be best summarized by a circuit. This is going to be an AC system. So we've got our AC source here. It's connected to this step-up transformer. And this is an ideal transformer. The distribution system has a resistance associated with it. And then we've got a step-down transformer. That step-down transformer is also ideal, and then it serves our load here. We know that the turns ratio here is 1 to 500. Turns ratio here is 500 to 1. This resistance is 3 ohms, and this resistance total was 0.3 ohms. We also know that the supply voltage was 120 volts right there. So to solve this, we want to find VAC and the efficiency of the system eta. Okay. The solution to this is that we're going to apply our rules that we learned for transformers. I'm going to have three currents here. We've got I3, I2, and I1. Try to get this on the screen just where I want it here. Okay, that's all right. I think you guys can see that okay, although that resistor is a little off. There we go, perfect. Okay, so I3 we can solve just by taking 120 volts and dividing it by 0.3 ohms. That's that same value we just had, so 400 amps in this circuit right here. I know that I2 and I3 are related, the currents are related by the inverse of the turns ratio right there, so I can just solve for I2. That's going to be equal to I3 divided by 500 to 1. And so that's going to give me an I2 of 0.8 amps. I1 is related to I2 by the turns ratio of this transformer right here, so that's I2 divided by 1 over 500. And so that's just gets us back to 400 amps. So 400 amps in the load circuit, 0.8 amps in the distribution circuit, and 400 amps in the generator circuit. So we've got our currents there. Next, we can calculate the voltages in the system. We know that there's 120 volts across the load, and since this is an ideal transformer, there's 120 volts across the terminals of this transformer. So the voltage of transformer 2's secondary side is going to be 120 volts. The voltage here, the primary, is going to be related to the secondary by the turns ratio, so 120 times 500 to 1. Right? The voltage on this side is 500 times what it is on this side, so that gives me a voltage of 6 times 10 to the 4th volts. So now I know the voltage right here. I need to know the voltage here, but there's a voltage drop associated with this 3 ohm resistor due to the current flowing through it. So I need to calculate that. Next, we'll call that VR3. That's the current through that, 0.8 ohms, or 0.8 amps, times 3 ohms. So that's 2.4 volts. I can then say, you know what, I'll just work over. Sorry guys, there's a little lag in the computer for some reason right now. Anyway, I can say that the voltage here is just the voltage drop here plus that application of KVL around that. So voltage in transformer 1's secondary is going to be equal to 60,000 volts plus 2.4 volts equals 60,002.4 volts. The voltage on the primary side of transformer 1 is just related to the voltage on the secondary side of transformer 1 by the turns ratio, so V21 primary is going to be equal to 60,002.4 volts times 1 divided by 500. So for every 500 volts on this side, we get 1 volt on that side, and that gives us 120.005 volts on the input, which has to be equal to VAC for this ideal transformer. So VAC is equal to 120.005. The power to the load, it can be just most easily calculated by voltage times current. We know that there was 400 amps in that load circuit times 120 volts. So 400 amps times 120 volts is equal to 48 kilowatts. And then we've got power in the sourced by this guy is just going to be equal to 120 volt, 120.005 volts times 400 amps. Because remember, the current here was the same as the current here for this ideal case. And that gives us 48,002 watts. The efficiency of the system is 48,000 divided by 48,002, multiplying by 100% to convert it to a percentage, and we get 99.99958%, excuse me. So that is our efficiency, and this is our supply voltage for this transformer circuit. So there's the solution to that problem.